Oh, hi, Mr. Enyard here. This will be morning work for Tuesday, week 31. I hope you enjoy it. Have a great day. All right, week 31, Tuesday, and we are again starting with volume, and the formula for volume is length times width times height. And so we have our 7 times 3 times 7. So we'll do 21 times 7, because I did 7 times 3, which is 21. And that's going to give me 147. And that's going to be the units, which is centimeters. And I did the three things, right? Length, width, and height. And so those three things are why I'm going to be able to say that I'm making little cubic units. Now remember, when I say cubic units, that means I'm literally cutting this into 147 pieces that make 1 by 1 by 1 cubes. So a whole bunch of these inside there. And again, I got a video on this on Edpuzzle called Volume and Surface Area. So go check it out if you're still not sure on how to do that or why it is that. The more you understand it, the easier they become. So number 2, we're just going to have 3 times 8. And that's because I did 1 times 3. And then that's 3. And then times my height, which is 8, because it's length times width times height. And that's going to give me 24. And then my units are yards. The units that I'm measuring with are yards. And remember, cubed to the third power. For number 3, we're looking for the median, which is the middle. And in order to find the middle, we have to first put all of our data in order from least to greatest. Just like that. So you can see I have 1, 2, 3, 4, 5, 6, 7 numbers. I have 7 up here, so I'm done. And my middle number will be that fourth number, which is 62. So 62 is my median. And another data question here. We're going to find the minimum, the maximum, and then the quartiles. So remember, the first thing we need to do is put them in order from least to greatest. So there I have my list, and minimum means the smallest or least number, so I'm going to put my 2 there. Maximum means the biggest number, so I'm going to put my maximum there. And then the quartile 2, remember, is the same thing as the median, which I'm just going to draw a line right through that 5, because that's right in the middle, so quartile 2 is 5. Now I can go and find the median of the first half of my data and the second. And that means we have 4 and 7. So with mixed numbers, and these are mixed numbers because we have a whole number and a fraction touching, so this is 3 and 5/6, so we almost have 4, but we're only a fraction of the way to 4. And this is almost 3, well actually it's just over 2, because 2 and 1/8. And the problem is when we divide these, even if we made like denominators, to divide the numerators, what would you do with the whole numbers? So you have two options. You can turn them to decimals and do 3 point something, and 2 divided by 2 point something, which you could set up and do pretty easily since we know how to divide by decimals, or you can make these improper. Well, I will tell you I'm making these improper because sixths are a derivative of thirds, which are irrational numbers, and it will last forever on decimals, and it won't be exact. So I'm going to make these improper by multiplying the denominator and the whole number to find how many sixths are in 3 wholes, which is 18, and then adding my extra 5. So 18 plus 5 is going to give me 23 sixths. And then 8 times 2 is 16, and 16 plus 1 is 17, 17 eighths. Okay, so now I can do two things. I can multiply by the reciprocal, which would be keep, change, flip, or I could make like denominators, and of course the lowest like denominator would be 24. But I'm just going to do keep, change, flip. I'm going to do the multiply by the reciprocal rule. So I'm going to change division and multiplication, and then I'm going to flip 17 eighths to 8 17ths. Now, some of you might know that as butterflying, but I'm going to do it like this. And so these are arrows, not a times sign, for those who know butterflying. So 23 times 8 will go on top, and then 6 times 17 will go on bottom. And so I did those up here, and I got 184 over 102, which means I can now make this it is improper, I can make it a mixed number and reduce. And so if I take 102 away from 184, that leaves me 82. So I can make one whole, right? Because a whole would be 102 102ths. And then that leaves me 82. And since these are both even, I know I can reduce it even more. I'm going to divide them both by 2. So I'm just going to bring that down over here. And so I've got one whole, and then 82 divided by 2 is going to be 41. And 102 divided by 2 is going to be 51. And those are prime numbers, I believe. Well, no, this one is divisible by 3. So that's not a prime number, but 41 is. And therefore, I am going to leave it just like that. 1 and 41 51ths. All right, and we're going to be finding the area of these figures. So we're going to have to do some cutting up or dividing imaginarily. I'm going to do it like this, which makes this a 3, not that it matters. But that means that this entire thing is 7, just like it is down at the bottom, right? Opposites are the same, and that means that this is 2 and this is 2. So all of that's fun, but bottom line is we have a 3 by 2 rectangle here, which is going to be 6 meters squared. And then we have a 7 by 2 rectangle there, which is going to be 14 meters squared. And now I just combine my two shapes, and I get 20 meters squared. So same thing here. I'm going to cut this right there, making it a 7 by 2 rectangle, which is going to be 14. And then this is going, and that's feet squared, right? Feet's my units, and then it's squared. And then 6 by 8 is 48 feet squared. And now I just add my 48 and my 14, which is going to give me 62 feet squared. So here's where I like these, because you have to pay attention. You can't just pick numbers that you find a pattern. Ooh, 3, 4, 5. Okay, so these are just going up 1. No, they're not. 1 to 3 skips 1, right? Skips 2. And then 5 to 7 skips 2, and 7 to 9 skips 2. So there's not going to be a direct pattern going left to right. These are big boy, big girl tables, right? Ratio tables are using multiplicative relationships between the numbers. So 1 to 3 is times 3, right? 1 times 3 gives you the bottom number. And then I can check that over here. Does 4 times 3 give me 12? Does 5 times 3 give me 15? How about going up? What's 12? What do I do to 12 to get 4? Well, the opposite of times 3, which is divided by 3. So let's do 3 times 3. Let's do 7 times 3. And 9 times 3. And there we go. All right, so to find the area of a trapezoid, we need to draw a 90-degree angle from the bottom to the top in this case. And so I'm just going to do it with the dotted line right there, and I'm going to say that that is 90 degrees, or a right angle, okay? And since this right here, from here to here, right, that's 6, that means from here to here, right, by making a 90-degree angle makes a rectangle, is also 6. So that means that this leftover piece, or the base of my triangle, is 2, since the total was 8. You see that? And now my height, right, we're going to go with that 5 right there. That's what the 5 is. It's how tall it is from the bottom to the top, which makes sense because it's less than the diagonal. So we don't need the diagonal. That is no longer important. What we need is to do a 6 by 5 rectangle, right? Height of 5, length of 6, which is going to be 30 kilometers squared. And then remember, triangles are base times height divided by 2. So we've got 2 times 5, which is 10, divided by 2 is 5. And we're going to add those together and get 35 kilometers squared for our total area of the trapezoid. Okay, so the last one, our proportion. Oop, wrong button. Our proportion is that a pound is 16 ounces in weight. And so if we have 3 of those pounds, right? So here's 1 pound. And that 1 pound is equivalent to 16 ounces, right? We're going to just duplicate that twice. So there's another pound. That's 2. I don't know what just happened there. And here's another one. That's 3. All right, 1, 2, 3. And each of them, right, isn't that worth 16? So what am I doing with 16? Yeah, I'm multiplying it by 3. And that makes sense because ounces is our smaller unit. And the smaller unit, it will take more of them to equal the same value or same amount of the bigger units. So 16 times 3, right? 32 plus 16 is going to be 48 ounces. So again, our problem was 3 times 16, and our portion was there. So you'll see something like this. 3 pounds over blank ounces, right? We don't know that. And we're going to say that we're going to use our 1 pound to 16 ounces proportion, right? And so if you notice, isn't that times 3 going left? So what should I do to this to make an equivalent ratio or equivalent fraction? Times 3. So that's another way you can always set it up to make sure you're using the right operation, not dividing, multiplying, if the size of the units does not make sense to you yet as to why the smaller unit always has more and the bigger unit always has less.